For this 460 volt, 60 hertz, 4-pole, 1740 RPM induction motor, whose per-phase equivalent circuit parameters are as follows: R1, 0.25 ohms, R'2, 0.2 ohms, X1, 0.5 ohms, X'2, 0.5 ohms, and Xm is equal to 30 ohms. Our task in this problem is to calculate the current and slip at full load. In order to calculate the full load slip, first we must find the synchronous speed in RPM, and that depends only on the frequency and pole count. In real terms, that is equal to 120 times 60 all over 4, which equals 1800 RPM. The percent slip at full load equals the synchronous speed minus the speed at full load divided by the synchronous speed times 100%. Plugging in our actual values, we get 3.33%. A quick physical note: slip tells us how far the rotor lags the rotating magnetic field. Small slips, a few percent, are normal at rated load. Larger slips mean the motor is more heavily loaded and losing efficiency. Remember that the per-phase voltage V1 is equal to the phase-to-phase voltage 460 all over root 3, which equals 265.58 volts. The rotor impedance, referred to the stator at slip, is ZR, which is equal to Jx'2 plus R'2 plus R'2 all over S, times the quantity 1 minus S. Let's deal with this equation one piece at a time. First, let's look at the fraction R'2 all over S. That equals 0.2 all over 0.0333, and ultimately that will be reduced to 6 ohms. Now let's look at the same fraction multiplied by the quantity 1 minus S, which is 6 times the quantity 1 minus 0.033, and that works out to 5.80 ohms. Now let's expand out a little further and add R' to this quantity, which when solved gives us the real portion of the rotor impedance ZR, which is 0.2 plus 5.80 ohms. And we find that simplifies out to 6 ohms. Now let's add the reactive component Jx'2 to that figure, and finally that works out to 6 plus J 0.5 ohms. In order to find the full load current, we're going to have to parallel the total rotor impedance with the magnetizing reactance Xm. That parallel combination, Z parallel, is equal to ZR times Xm all over ZR plus Xm, which ultimately works out to 5.589 plus J 1.591 ohms. Now the total input impedance per phase, Z1, is equal to the stator impedance, Zs, in series with the parallel rotor impedance, Z parallel. And that works out to 5.839 plus J 2.091 ohms. Now that we know V1 and Z1, we are in the position to calculate the full load current magnitude. Ohm's law tells us that the current will be equal to the applied voltage magnitude over the current magnitude. And those values already have been calculated. 265.58 volts divided by 5.839 plus J 2.091 ohms. In order to carry out this calculation, we need to convert the impedance Z1 to a magnitude, which is the square root of 5.839 squared plus 2.091 squared, and that equals 6.203 ohms. So the current magnitude will be 265.58 all over 6.203, giving us the current magnitude at full load equal to 42.75 amps per phase. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure you're not left in the dark when the next storm hits. EcoFlow is having a super prime big deal days for a limited time only. Check them out at these sites: EcoFlow Canada at this web address and EcoFlow USA at this web address. You can also use coupon code 25PDFAFF to realize an extra 5% discount.